Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Now, let's begin. Today, let's discuss an easier problem. First, find two values of n so that 2n minus 1 is divisible by 7. So we can make this problem simpler. So we can think that this problem is find all values of n so that 2n minus 1 is divisible by 7. I mean 2 to the square of n. Okay, so let's assume n is 1 and the result is 2 and the remainder is 2. Let's assume that n is 2. The result is 4 and the remainder is 4. Let's assume that n is 3. The result is 8 and the remainder is 1. Let's assume that n is 4. The result is 16 and the remainder is 2. Let's assume that n is 5. It's 32 and the result is 4. I mean the remainder is 4. Let's assume n is equals to 6 and the answer is 64 and the remainder is 1. Let's assume n is 7. The answer is 128 and the remainder is 2. Let's assume that n is 8. The answer is 256 and the remainder is 4. Let's assume that n is 9. The answer is 512 and the result is 1. Let's assume n is 10. The result is 1024 and the remainder is 2. So 1 is 11. It's 2048 and the remainder is 4. 1 is 12. The answer is 4096 and the result is 1. So, what we can discover here is like when 3k when the n is equals to 3k plus 1, while k is in the element of 0, infinity. If this means that k is in the range of 0 and infinity, then the divisor, I mean the remainder will be 2. So, when n is in 3k plus 2 and k is from 0 to infinity, the remainder will be 4. And when n is equal to 3k, well, at this point k is in the element of 0 to infinity, the result will be 1. I mean the remainder will be 1. So when we do so, well, now let's put it back to 2 to the power of n minus 1. If 2 to the power of n has remainder 2, when it minus 1, it has the remainder of 1. And it is not divisible by 7. When the 2 to the power of n have the result of 4, when it divides 7, and when we minus 1, the remainder will be 3, which is also not divisible by 7. Let's try that when 2 to the power of n has remainder 1 when divided by 7, and when it minus 1, it is totally okay to be divisible by 7. What we mean is that only when n is equals to 3k, while k has a range of from 0 to infinity, while k is a natural number. So only this range of n is okay. So let's answer the first problem. When n is equals to 3k, while k is a natural number and k is in the element of 0 to infinity. Okay. Let's answer the second problem. Prove that there is not any natural value of n, so that 2 to the power of n plus 1 is divisible by 7. So, using the idea before, when n is in 3k plus 1, while k is in the element of r, and k is a natural number and k is in the element of 0 to infinity, like this. At this point, the remainder of 2 to the square of n is equal to 2. So we try when n is equal to 3k plus 1, and then it's plus 1 again, which means the remainder, when 2 to the square of n divided by 7 has a remainder of 2, and it adds 1. It will have the remainder of 3. It has a remainder of 3, which means it's not divisible by 7. Okay, now let's try n is equals to 3k plus 2. As I have said earlier, when n is in 3k plus 2, while k has a range from 0 to infinity, 2 to the square of n will have the remainder of 4. And when we plus 1, the remainder is 5, which is not divisible by 7. So 3k plus 2 is also not okay. Let's try when n is equals to 3k, while k from 0 to infinity. As I said earlier, when n is equal to 3k, the remainder of 2 to the square of n is 1. And when we plus 1, we get 2. 2 is also not divisible by 7. Therefore, when n, no matter when n is in 3k plus 1, 3k, or 3k to 2, they are both not divisible by 7, which means that 2 to the power plus 1 when n is in the element of r, of natural number, is not divisible by 7. The end. In fact, problems, They have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!